I want to leap over buildings, want to fly over the shores, save the people from the villains, catch the crooks who rob the stores, write my name upon the sky, and when you call me, I'll be there, faster than a lightning flash, rushing through the cool night air. So start ignition, count to zero. I just wanna be a superhero. Thoughts, emotions swirled. I wanna be the man that saves the world, yeah.
The enormous increasing in population in the worldwide led to increase the requirements of energy, which is related to the different services for the daily human living. The rising demand on energy caused raising the greenhouse gases emissions that have negative impacts on both the environment and the human's health. Reducing these emissions could be achieved by sustainable architecture, which is an approach for the building that protects air, water, and soil by selecting environmental friendly materials of the building and adopting eco-friendly practices during the construction. This study is aimed to analyze the natural daylight design of the mosque available through the openings, which are windows, improve the daylighting in the mosque by utilizing the glazing for dome with different 3 scenarios, and finally to minimize the lighting load of electricity for the mosque by relying on the available natural daylighting. ASBE Mosque, which is also known as Ottoman Mosque, is considered as the oldest mosque in the UAE. It was built before than 400 years ago. ASBE Mosque is located in the north of Fujairah, and it consists of the prayer hall with a prayer mihrab, pulpit, and openings. A central pillar divides the internal spaces into 4 squares of similar dimensions. Until today, ASBE Mosque is a main tourist attraction in Fujairah. The case study of this research is about Al-Khawanij Mosque, which is located in Al-Khawanij area in Dubai, UAE. A site visit for Al-Khawanij Mosque was carried out as the following figures. The methodology of this study was to select a case study, which was Al-Khawanij Mosque that is located in Dubai in Al-Khawanij Area 1. A site visit was carried out into Al-Khawanij Mosque. Besides, the climatic data of Emirate of Dubai was collected, and also the maps and drawings and plans for the mosque. After collecting the data, the simulation was carried out using the IES software for the passive strategy design, which was glazing in this case. For the first scenario, the base case was simulated, while in the second scenario, we used one single row glazing dome. And the final scenario it was glazing the dome with 2 levels of windows. The results was compared, and the optimum scenario was selecting for the glazed strategy. The mosque was built in the IES software as its actual design. The mosque was simulated within 3 different scenarios. The first one was as the base, and the second one was with glazing the dome with 1 row of windows, while the third one was glazing the dome with 2 levels of windows. For scenario 1, and by comparing the results between summer and winter seasons, it was observed that the daylighting in January is better than July, although the far inside areas is still dark. For scenario 2, there is an enhancement for the daylight inside the prayer hall of the mosque once we add 1 row of windows to the dome. In scenario 3, where the dome was glazed with 2 levels of windows, there was a significant enhancement in the daylighting inside the prayer hall of the mosque. By comparing the total energy consumption between scenario 1 and scenario 3, it was noticed that there was a significant reduction in consumption energy, especially when we use the passive design of glazing the dome with 2 levels of windows, with approximately 20% reduction in megawatt hour. The following tables show you the total consumption of energy before and after applying the passive design of glazing for the dome of the mosque. In conclusion, implementing strategy of glazing the solid concrete dome of the mosque with 2 rows of glass has recorded a reduction of energy consumption. Respectively, the total cost of operating the mosque will be reduced as a result of that. Besides that, increasing the number of levels of windows, more than 2 on the dome, may lead to increase the unwanted glares and respectively will increase the thermal heating inside the mosque. This will lead to utilizing more the air conditioning, which will raise the energy consumption, and that conflicts the principle of sustainability.